Hello, welcome back. In this lecture, we're going to focus more on the conflicts between the net present value method and the internal rate of return method when we are evaluating mutually exclusive projects. So just to recapture what we have talked about, the net present value method measures the change in value to the firm. So this is a dollar amount. Um, Whereas the internal rate of return measure the percentage return of a project. Um, just as a rule of thumb, whenever there is a conflict between the net present value and any other methods, we should always go with the net present value method. And that's because as we look at the advantages and disadvantages of various methods, the net present value method is the one that has the most desirable qualities. And to reiterate, the internal rate of return method is unreliable in two situations. One is when we have non-conventional or cash flows that changes signs more than once, and the other is when we are talking about mutually exclusive projects. We already said that the solution to the non-conventional cash flow problem is to compute the modified IRR or MIRR instead of the regular internal rate of return. Now we're going to take a look at what do we need to do when we are evaluating mutually exclusive projects. So here's an example of two mutually exclusive projects. Before we continue, I'm going to ask you to pause the video and then evaluate each project on your own. So here we have project A. These are the cash flows associated with project A. So pause the video and compute the internal rate of return and the net present value for project A, and then compute the internal rate of return and net present value for project B. So pause the video now and make sure that you get the same answers that you see in front of you. So we find that when we use a discount rate of 10%, project A has a higher net present value. So if we are going with the net present value method, we will choose A. However, if we are going by the internal rate of return method and we compare the IRR for project A and project B, we will see that project B will have a high IRR, so we're going to choose project B. So now if you imagine two teams that were sent off to analyze this project, and team A was instructed to use the net present value method, and team B was instructed to use the internal rate of return method, the two teams is going to come back and they will recommend different projects, and they will both have equally valid rationale. And that really make decision making extremely difficult. So the final question then is, which project should you accept and why? The short answer to that is we should accept project A because we want to go with the net present value method. So after we decided that we'll choose A based on the net present value method, we really haven't answered the question why. So that's the purpose of this lecture, is to go into answering why that is the case. So before we do that, I want to introduce a concept. We want to draw the net present value profile for these two projects. So again, I'm going to ask you to pause the video and then go ahead and compute the net present value profile for these two projects. And as you remember, in order for you to compute the net present value profile, you need to compute the net present value at different discount rate. So let's pick the discount rate again at 0%, 5%, 10%, 15%, and 20%. And 25%. So go ahead and do that and compute the net present value profile. Did you get this answer? Again, pause the video and double check your calculation to make sure that you get the right numbers. So one of the things that you notice when you compute the net present value profile for project A and project B is that you saw that the decision based on net present value is not always the same. In fact, at the original discount rate of 10%, we saw that project A is a better project than project B because project A at 10% has a higher net present value than project B. So in other words, if the economic condition continue as we expected and there's no surprises, there's no new information, we should go with project A. However, if there are significant changes to the economic condition, let's say a sudden surge in oil prices or changes in the geopolitical environment, which cause interest rate to increase sharply, say interest rate goes up to 15%, you saw that the decision could be different. The net present value of project B is higher than the net present value of project A. One thing that's very important is we cannot choose the discount rate. The discount rate is a given. So think of the government, the Federal Reserve Bank, trying to set a target interest rate. And even the Federal Reserve and the government has only marginal influence over the interest rate. In the short term, they have quite a bit of influence, but in the long term, so again, we are talking about long-term projects, even the government's ability to influence interest rate is limited. The overall interest rate depends on the global economic conditions across the globe. So when we do long-term project analysis, we want to do scenario and sensitivity analysis. What that means is we want to take into account different possible events in the world. So today's economic conditions suggest that the correct discount rate is 10%. But we want to ask the question, what if? What if something drastic happened and the discount rate goes up to 15%. And here we have the answer. If the discount rate goes up to 15%, then project B will be the better project. The next question to follow up in that case is to ask what is the probability of that event happening. Okay, so remember that when we develop the net present value profile, we also want to present them as a graph. And here is what the graph for the net present value profile for project A and project B will look like. So this is project A, and over here is a project. So just to reiterate, the discount rate where the net present value goes to zero is the internal rate of return. So for project A, the internal rate of return is 19%, so slightly less than 20%. And for project B, that is higher than 20%. In fact, it's at 22.17%. So you can see that the net present value profile of project A crosses over the net present value of project B. And this introduces a new concept called the crossover point. If the appropriate discount rate is less than the crossover point, meaning on this side, we saw that there is a conflict between the decision rule based on the net present value rule and the IR rule, because left of the crossover point, meaning when the discount rate is less than the crossover rate, project A will have a higher net present value than project B. Whereas to the right of the crossover point, meaning when the discount rate is higher than the crossover point, then the net present value for project B will always be higher than the net present value for project A. And since the internal rate of return for project B is always higher than the internal rate of return for project A, when the appropriate discount rate is right or greater than the crossover point, we won't have a conflict. So what we want to ask in the most important question is, what are the probability of the discount rate being to the right of the crossover point? And that is an empirical question. That's something that you have to answer with knowledge about the industry and also knowledge about the current economic and geopolitical condition. And that is something that we're going to address in a later chapter. You'll also learn more about that in an economics course. The next thing that I want to touch upon, though, is the technical calculation of the crossover point. How do we compute this crossover rate? There are two steps to computing the crossover rate. The first step is to compute the difference in the cash flow. So we need to take the cash flow for project A and subtract the cash flow from project B. So if we take negative $500 minus minus $400. So the difference there is negative $100. Again, we take the cash flow for each year and subtract the difference. 325 minus 325 is 0. And then 325 minus 200 is 125. So here we have the difference in the cash flow. Next, we compute the IRR on this difference. So the first thing we do is we want to clear the cash flow. So we'll do second function clear work. And cash flow in year 0, the difference is $100, but is negative. So we'll enter that. And cash flow in year 1, the difference is 0. So we'll just enter 0. And then the cash flow in year 2 is 125. And we'll enter that. And that's all that is. And we'll compute the internal rate of return. So press IRR and then press compute. So we have the crossover rate of 11.8%. So here's where the 11.8% comes from. And you can see in the graph that is the point where the two net present value profile intersect or cross each other.